Hello everyone. So let's now solve practice assignment week 9 question number 4. Consider two functions f and g defined as f of x comma y is x square comma y square, g of x comma y is x square minus y square divided by x square plus y square when x comma y is not equal to 0 comma 0 and 0 when it is equal to 0 comma 0. So which of the following options are true? The first option says about finding g of f x comma y. So for finding g of f, we will put the output of the function f as the argument of the function g. So that means we'll find the output of the function f is x square comma y square, and on putting that as the argument of the function g, we will get x square square minus y square square divided by x square square plus y square square when xy is not equal to 0 comma 0 and 0 and xy is 0 comma 0, and that would be the second option, not the first option. So second option is correct, first option is wrong. Now the limit when xy tends to 0 comma 0 for the function g exists. Now the function g of x comma y is defined as x square minus y square divided by x square plus y square, and x comma y is not 0 comma 0 and 0 and it is 0 comma 0. Now we have to find the limit for this function when xy tending to 0 comma 0. Now we know that if we put directly put the 0 comma 0, the function is undefined. So we will try to find the limit across different paths, and the first is we will try to find the limit along the line y equal to mx, where m is the slope of the line. So we will basically replace y with mx in the function g. So now function g would be just the function of x only, as y is replaced with mx, and if we just expand it, so the limit value would be 1 minus m square divided by 1 plus m square. So one can see that the limit is path dependent, that is the limit will change when the slope would be different. So for example, if we choose m value to be 2, that is along the line y equal to 2x, the limit we will get is 1 minus 2 square divided by 1 plus 2 square, that is negative 3 by 4. And for the line, let's say y equal to some 5x, we'll get limit to be 1 minus 5 square divided by 1 plus 5 square, that is negative 24 by negative just 26. So across different lines and path and direction, we are getting the different limit. So the limit does not exist. Limit for the function g of f x comma y when xy tends to origin is exist. So the same thing that we did for the function g, we can do for g of f x comma y, that is x4 minus y4 divided by x4 plus y4, and xy is not equal to 0 comma 0 or otherwise it is 0. So same, we have to find the limit when x comma y tends to origin for the function g of f x comma y. We will find the limit along the line y equal to mx. So again, the function g of f would remain with just the function of x, as we are replacing y with mx. So it would be same as just the finding when x tending to 0, x4 mx power 4, and we will just get the 1 minus m4 divided by 1 plus m4. So again, the limit is path dependent, so the limit does not exist. Now, the next option tells that limit x tends to 0, limit y tends to 0 for the g of f x comma y, same as limit y tends to 0, limit x tends to 0 for the function g of f x comma y. So This is and the rest two options is the limit when x tends to 0 and y tends to 0, y tends to 0, x tends to 0. So how the way to solve this is first we will just solve this much part, that is find the limit when y tends to 0 for the function g of f x comma y, and then whatever the output that we will get, we will take that as the function and then find the solve this part with that function, that is limit x tends to 0. So we have to find limit x tends to 0, limit y tends to 0 for the function g of f x comma y, and in that we will just first solve this part. So our g of f was again defined like x4 minus y4 divided by x4 plus y4, and xy is not equal to 0 and 0 otherwise. So we will be only solving first this part. Now here we can directly put the y value to be 0, as in that case the function will not be undefined. So if we just put y equal to 0 and x to be remain as x, so the limit that we would get is the limit x tends to 0. The outer part limit will remain as it is. For the inside, we will get 0 power 4 divided by x4 plus 0 power 4, and that we will get is x4 divided by x4, that is limit x tending to 0, 1. Now we will find, uh, we will solve this, as now there is no x present here, so the limit would be just 1. So this is the LHS side part. Now we have to solve that if whether this part is equal to the this part, that is the limit that we will get after solving this should also be equal to 1. So let's try this. Now tends to 0, limit x tends to 0 for g of f x comma y. Notice there's a difference between what we did first. First here, we first find the limit with y and then with x, while here we will first find the limit with x and then with y. So just like we did before, we will first solve this much part, and because again for finding the limit when x tends to 0, the function does not become undefined here. So we can just directly put x value to be 0 here, and we'll get is this outer part will remain as it is, and inside we'll get 0 power 4 minus y4 divided by 0 power 4 plus y4, y tends to 0 minus y4 divided by y4, and that is just negative 1. So this is the limit that we will get. But for the above case, we got limit as 1. So these two are not equal. So that's why it is wrong. And yeah, this part we get as 1, while the second part we get as negative 1. So this is the correct. Now, limit when x comma y tends to 1 comma 1 for the function g does not exist. Now, if we look at the function g, if we put 1 comma 1 in the function g, the function does not become undefined. So we can just directly find the limit by just putting the value 1 comma 1 in the function g, and if we put 1 comma 1, the limit that we will get is 0. So the limit does exist when xy tends to 1 comma 1. So this is wrong. Thank you.